In Chapter 9, Part 1, we are looking at an introduction to inequalities. So we are looking to see what is the similarity between x is greater than or equal to 2 and x equals 2. So the similarities is that they are both equal to 2. The difference for x is greater than or equal to 2, x can be 2 or larger, where x equals 2 is just x equals 2. So how many solutions does an inequality such as x is greater than or equal to 2 have? This is going to be infinite solutions. So there are so many, we can't count all of them, numbers that are larger or equal to 2. So it could be 2, 3, 4, 5, 6, 7, 8, to infinity. So there's infinite solutions. Number 2 asks, how many solutions does this inequality have? Negative 1 is less than or equal to x, which is less than or equal to 4. And you want to be careful because you don't want to say, oh, well, it's negative 1, 0, 1, 2, 3, and 4. Because, yes, they are the whole numbers that satisfy this inequality, but you're missing all the other numbers in between. So we are going to say that any number from negative 1, including negative 1, to 4, including 4. So any number from negative 1 to 4, including negative 1 and 4. So we're going to look at an open point. So this is the value that is not included. So think about when we did domain and range. When we had an open point that got parentheses, it was not included. So an example, for less than, x is less than 5, we're going to have an open point at 5 because it's less than. And since x is less than 5, we're going to draw an arrow to the left. So everything to the left would be less than 5. For greater than, we are going to have an example of r is greater than negative 3. So we're going to have an open point because it is greater than. And since the greater than, r is greater than negative 3, those are going to be all the values to the right of our point. For our closed point, this is something that is included. When we talked about domain and range, this was an included point. We gave it brackets. So we have an example that m is less than or equal to negative 1. So we are going to have a closed point now at negative 1. And since m is less than or equal to, everything smaller to the left would be included. For greater than or equal to, t is greater than or equal to negative 2. We'll have a closed point at negative 2. And since t is greater than or equal to, our arrow is going to go to the right. So we're going to take a look at what's called a compound inequality. So compound is going to have two things going on here. It's going to be represented using the words or and. So the and compound inequality, you will see them being written together. So in this example, negative 2 is less than z, which is less than or equal to 5. So we are going to have an open point at negative 2, a closed point at 5, and everything in between is going to be included. So and the 2 points you will plot, and then they're going to go towards each other. For or, they're going to go in opposite directions. So think or, opposite. So we are going to put a point at, open point at 3. So x is greater than 3, so everything larger than 3 would be included. Or x is less than or equal to 0. So a closed point at 0 with an arrow going to the left. So this is an or inequality. They're going in opposite directions. The and, they are going towards each other. So in example 3, we are going to write an inequality that represents what's going on the number line. So in part A, we have this or relationship. They're going in opposite directions. So we're going to write them as two separate inequalities. So we have x is less than or equal to negative 3. It's less than or equal to because of that closed point. Or x is greater than, because it's an open point there, 2. So either x is bigger than 2 or it's less than or equal to negative 3. Part B, we have an open point at 1, and the arrow is going to the left, so it's all the values less than. So we're going to say x is less than 1. Part C, we have a closed point, and the values are getting smaller. So x is less than or equal to 3. And then for D, we have an open point and a closed point, and then they're going towards each other. So this is that and inequality. So we're going to have negative 4 is less than x, which is less than or equal to 2. So solving inequalities, we are going to solve 2x minus 5 is greater than or equal to negative 3. So we want to figure out what is the smallest solution to the inequality. So prior to that, we are going to solve for x. So we're going to solve like a normal equation. We're going to add 5 to both sides. So 2x is greater than or equal to 2. Divide both sides by 2. So x is greater than or equal to 1. So what is the smallest solution? Well, if x is greater than or equal to 1, the smallest number is going to be a 1, or it's going to be 1 or larger than that. So a boundary point, that is the starting point of the solution. So if we are to graph this, we are going to start at 1 with a closed point and have an arrow going to the right. So 1 would be the very first number that would satisfy this inequality, and then we would go up from there. There's a special note here that when you are dividing or multiplying by a negative, you are going to flip your inequality sign. This is very, very, very important. If you do not do this, you're going to run into mistakes, so you must flip that inequality sign. And we'll take a look at some examples here in a second. So looking at number 5, we have m plus 5 is greater than or equal to 3. So we're going to start by subtracting 5 on both sides. So we are solving like a regular equation. So m is greater than or equal to negative 2. Since that m is by itself, we are done. So on our number line, I'm going to put a couple points. We have our closed point at negative 2. And since m is greater than or equal to, it is going to go to the right. Number 6, negative 3x is greater than 9. So we are going to start by dividing everything by negative 3. Since we are dividing by a negative, that inequality symbol is going to reverse, and now as x is less than negative 3. So this is very important. We are taking that inequality symbol, and because we are dividing by a negative, or if you multiply by a negative, it is going to change directions. So now, on our number line, we're going to have a point, open point at negative 3, and since x is less than negative 3, our arrow is going to go to the left. Everything smaller than that would satisfy that inequality. Number 7, we want to get y by itself. Y divided by 2 is greater than or equal to negative 1. So we're going to multiply both sides by 2. So y is greater than or equal to negative 2. So on our number line, we'll have a closed point going to the right. The last one we're going to look at this page is number 9. And we are going to start by adding 4x to both sides because we want to combine like terms. So it'll leave us with negative 8 is less than or equal to 0 because these are going to cross out. So we want to decide, is this a true statement? Is negative 8 less than or equal to 0? Since this is true, we are going to say that it is all solutions or many solutions, or you could say infinite solutions. So anything is going to work. So you would have a line forever. So no matter what you plugged in for x back into the inequality, it would always, always, always work out because this is a true statement. So looking at compound inequalities, we are going to take a look at number 11, and we are going to solve for x. And this is an OR inequality, so remember that means we're going to have 2 points going in opposite directions. So if you don't have that, you know you made a mistake. So we're going to start by subtracting 2 from both sides of that first inequality. So x is going to be greater than or equal to 4. The other one, we're going to subtract 5. So x is going to be less than negative 4. So we have two things going on. So x is greater than or equal to 4, or x is less than negative 4. So on our number line, we're going to plot some points. So at 4, we have a closed point going to the right. At negative 4, we'll have an open point going to the left. And again, this should be an OR inequality. They should be going in opposite directions, which they do. In number 12, this is an AND inequality. As you see, they are all written together. So when we start, we are going to subtract 2 on all 3 sides. So that leaves us with negative 5 is less than n, which is less than 7. Now, once you write it as this compound inequality, you want to make sure that you are going from small to large. If you are done. So we are now going to plot this. So I'm going to plot a couple points on my number line. So I have an open point at 7 and an open point at negative 5. And then we are going to connect in between them. So anything from negative 5 to 7, not including those values, would satisfy that inequality. We're going to jump down to 14, and we want to get v by itself, and there is a lot going on in this problem. The first thing we want to do is we want to get rid of this negative 2. So since we're dividing by negative 2, we are going to multiply both sides by negative 2, actually all 3 sides. So now it's 0. And because we're multiplying by negative 2, it's going to change our inequality to 0 is now greater than v minus 1, which is now greater than or equal to negative 8. So what happened is, because we were dividing by a negative 2, those inequality symbols here are going to go in the opposite direction. So we will still continue to solve like normal. We're going to add 1 to both sides, or all sides. So we have 1 is greater than v, which is greater than or equal to negative 7. So before we call it a day and say this is the final answer, we want to make sure to see we are going in increasing order. So 1 is not smaller than negative 7. So we are going to rearrange this. So we have our negative 7 is less than or equal to v, because this is saying the same thing as that. It's just now the negative 7 is on the left. And then we are going to take this part, which says 1 is greater than v, and write that as v is less than 1, which still means the same thing. So we want to make sure that this is going in increasing order. So negative 7 is less than or equal to v, which is less than 1. So when we go to graph this, we'll have an open point at 1 and a closed point at negative 7. And then we will connect them together.